Hello again, and as I promised, here are some examples where we are going to follow the steps we looked at in the previous video to actually simplify some or solve some exponential equations. Okay, so as we said in the previous one, what we want to do is we want to get two terms, one on the left hand side, one on the right hand side. We want the two terms on the left hand side and the right hand side to have the same basis, and if they do, then we'll just equate the exponents. So you can see in this example we've got 5 to the power of x is equal to 625. Now again, it helps to know your exponents, to know that 625 is in fact 5 to the power of 4. Okay, and 5 to the power of x is equal to 5 to the power of 4, which means x must equal 4. Okay, isn't that simple enough? I think it is. Okay, let's look at the next question. Here we have, once again, we have two sides, a left hand side and a right hand side. We want the two sides to be the same, and what we're going to do is first of all to prime the bases. Here on this side, when we prime the bases, it wasn't necessary to prime the base here because it was already a 5, but here we will have to prime this base, which is 1 over, and this one would be 1 over 10, and 10 would be 1000 would be to the power of 3, and all of this to the power of x is equal to 10 to the power of, and 100 would be 10 to the power of 2. Now you'll notice that this, using our simplification process, simplifying this to be a base, we can write this as 10 to the power of negative 3. Hopefully you remember that 10 to the power of negative 3 is equal to 1 over 10 to the power of 3. So we can go the other way around, because what we have at this stage is that this whole bracket is a base, and they're not the same. So we're going to try and get this whole base here to be simply 10. And we do that by saying it's 10 to the power of negative 3. And then, okay, let me do that step. 10 to the power of negative 3 to the power of x is equal to 10 to the power of 2. So here we can see this is 10 to the power. Okay, I've got a power with an exponent, a power to a power. That means I multiply exponents, so that's negative 3x is equal to 10 to the power of 2. Once I do have my bases the same, it is very simple from there. I only equate my exponents. Okay, bases are the same, I equate exponents, and then I continue to solve masterfully my linear equation. Okay, that one was fairly difficult, I think, as difficult as the easy ones are or can get. Let's look at another one. Here we have two sides, left hand side, right hand side, and as a matter of fact we see we actually have on the left hand side an unknown and on the right hand side an unknown. What is very nice about this one is that we already have same basis on both sides, which simply means my exponents must be equal. I can immediately just say that 10 to the power of x minus 1 is equal to 10 to the power of 7x minus 8, which means x minus 1 must be equal to 7x minus 8 because this power is equal to that power. And then I can just solve it, and I'm not going to spend a lot of time showing you how I solve it. Hopefully you can do that. Negative 8, I can add an 8 on both sides, for example, and I get 7 is equal to, and because it's x, that is 7, and on the right hand side I get 6x because I subtract an x on both sides, subtract an x on both sides, and then I end up having x is equal to 7 over 6. I just divide both sides with a 6 to get x on its own, and I said I was not going to tell you how I do it, but I end up doing that anyway. So there I go, I get that one. Okay, now in this one might be slightly more difficult, probably because I'll first have to just use my calculator to find out, well, what exponent is this. This is 6 to the power of 3n plus 2. Now before I prime this base, usually I would prime the base. Before I prime the base, this base is going to be 2 times 3. Okay, it is probably unlikely that 2 times 3, and on this side I'll have a 2 and a 3 as well, so why not just keep to the 6? Why don't we just keep to the 6? Let's just get the calculator up here and see 6 to the power of what will give me 7776. So we've got 7776. How many times does 6 divide in there? 1, 2, 3, 4, 5. In other words, we counted 5 times that 6 can divide into it. Let's try 6 to the power of 5. 6 to the power of 5 is equal to, oh, there we go. So this 7776 is 6 to the power of 5. There I go. I've got two bases, two same bases. Now on the left hand and the right hand side, which must mean my exponents are the same. So 3n plus 2 must equal 5. And I don't know about you, but I can definitely spot this. 3 plus 2 is 5. That means n must be 1, so it's 3 times 1. N is equal to 1. Okay, in this one is probably easier than the one we had before. Okay, that one was actually, this one was fairly difficult actually. Okay, but this one is very similar. Again, I'm going to first just try and get the basis on both sides the same. And again, I don't need to prime it, because priming 100 would be 2 to the power of 4, 2 to the power of 2 times 4 to the power of 2. I'm just going to use 10, because I can see on both sides I'm going to have a basis of 10. So this is 10 to the power of 2 to the power of n is equal to, and this one would be 1, 2, 3, 4, 5 zeros, so that's 10 to the power of 5, but since it's 1 divided by the whole lot, it would be negative 5, 10 to the power of negative 5. So I end up getting 10 to the power of 2n is equal to 10 to the power of negative 5. That means 2n is equal to negative 5, so n must be equal to negative 5 over 2. There we go. Once again, very simple one to solve. Okay, let's look at this one. This one looks slightly more difficult, but actually it's very easy. Again, I see my bases are not the same. This is a 1 over 10 base, and this is a 10 base. But to get this a 10 base, I can only make it 10 to the power of negative 1. Remember, when I divide, my exponent gets a negative. So this is n plus 6 is equal to 10 to n minus 4. So now I just multiply the exponents, and remember I must multiply the negative one with both terms. So it's 10 to the power of negative n plus, oh not plus, negative 6 is equal to 10 to the power of 2n minus 4. And now same basis, which means my exponents must be the same, so I get negative 6, negative n, negative 6 is equal to 2n minus 4, and that will give me, I'm going to need some more space, so let's write here, that will give me negative 3n is equal to positive 2, so n would equal negative 2 over 3. There we go, we're doing well. Let's continue on this. We've got a few more questions, and they're increasing in difficulty slightly with each attempt. Okay, here we can see a similar example of what I did before in the previous video, where we've got two bases, and actually to get these two bases the same, I won't change one into the other. Like so far, that's what I've been doing. I've been trying to change one into the other. But here I'll actually have to change both of them. Okay, so this one will be 2 to the power of 4, but the 4 is going to multiply all of these exponents, so I'm kind of skipping a step here if you notice that. This will be 8x plus 8. Where does that come from? Again, this is 2 to the power of 4, and the 4 multiplies everything in that expression. this is 2 to the power of 3, and the 3 multiplies everything in that expression. So that's 9x plus 9. Same bases, single terms on both sides. Excellent, I can equate my exponent. That's 8x plus 8 is equal to 9x plus 9. Isn't that interesting? And then when we simplify this, this means x will equal -1. Okay, x will equal -1. Let's go to the next one. And in this one, we see a slight modification that we'll have to make here first. The modification we'll have to make is, I want you to notice that on the left-hand side, I do not just have a power. I've got a coefficient to that power. So let's start by getting rid of that coefficient. Just divide it on both sides. That leaves me with 2 to the power of n is equal to, and 3 goes into there 16 times. And now you can actually just use inspection to solve this one. That means n must be 4, because 2 to the power of 4 is equal to 16. Okay, but again, the first thing that you'll have to do actually is to just get your power on its own. And just a warning here, something that happens so often, it's scary. A lot of people say that this is 6n is equal to 48. They multiply the 3 and 2, and there's no law in exponentials where you can multiply the bases. Well, there is. The only time I can multiply bases is when the exponents are the same. So if this was also 3 to the power of n, yes, then it could be 6n. But it is not, so please do not continue to make that mistake. Let's look at this next one. This next one is very similar, slightly more difficult. Okay, and the only reason why is because I've got 3 terms all of a sudden. But that's not a problem, because I can just add the 1 on the other side, and then I just have 2 terms. Okay, so if I add a 1 here, I get 192. 3 can go, again, we see we've got this coefficient, so we divide away the coefficient. Okay, to get 2x, 3 goes into 19, it goes into 18 6 times. 1 remains to leave the 19, 3 goes into 12 4 times, so we get 2 to the power of x is 64. And again, because I know my powers of 2, I know that this is 2 to the power of 6, so x must equal 6. And here once again is a similar one, slightly more challenging, because I also have to use same basis method. Here in these two, I actually just used inspection. I got to a point where inspection was easy. Here I'm going to have to do same basis. So I've got 2 times 625. Again we see an exponent, sorry, a coefficient. I'll first have to, this one adds on that side 250 when I add 24 on each side plus 24 on each side. Then I divide with 2, so it's 625 to the power of 2 is equal to, divide both sides with a 2 to get rid of the coefficient. That gives me 125. Now priming the bases, or at least just getting the bases the same, I can see, sorry, this is not 2, that should be an x, I apologize. That should be an x. So here, this is 625 is 5 to the power of 4 times the x, and this side is 5 to the power of 3. And then I can see that, well, that means 4x is equal to 3, which means x is equal to 3 over 4. Well, that's my song for now. I hope these 10 examples have really covered most of the types that you should encounter, and I do think it would. In the next video we'll look at actually just slightly more complicated examples of solving exponential equations. I'll see you there.